Logan, are you ready? All right. Welcome. Thanks for coming, everybody. Welcome to the LASCON and OWASP community. Just a little show of hands to kind of wake you up in the mornings. How many people have been to LASCON before? Okay. Thank you for coming back. We appreciate it. And I would assume, how many of you are new, first time coming? That's fantastic. Welcome to the community. I'm going to tell you just a little bit about the community, and I'm going to introduce our speakers, Josh and Dan. So OWASP, especially for the new people, but I think some of this might also be of interest to those of you who've been to LASCON before. LASCON is an OWASP event. It's organized by the OWASP Austin chapter. And the OWASP Austin chapter was founded back in 2006. It's grown over the years. LASCON originally first started in 2010 and was founded by Josh Sokol and James Wickett, and created this conference. And we've had a great run, and we keep continuing to grow the audience, and we love to have new people, so we're welcome for all of you that are new, because we want to grow and expand the application security community and make sure that we're reaching out to all of our stakeholders, including developers and leaders, as well as business folks. So thank you for coming. A couple other facts about OWASP and OWASP Austin that might be of interest to you. We have our chapter is the one that organizes this conference. It's all volunteer driven. So while I get to stand up here and do the intros as the chairperson of the conference and co-chair of the conference, the work is really being done by all the volunteers. So Kyle and Griff, who checked you in this morning, and a number of other volunteers that you'll see throughout the day. And if you're staying for the rest of the conference, you'll see them in white shirts. So they're the ones who are putting in the hard work to organize this event. I just get up here and get to thank them and talk to you. But please thank them. And we also want to help invite you to join the community. The OWASP Austin chapter runs monthly meetings. So besides this conference once a year, we have monthly meetings. Usually the last Tuesday of every month. We take a break for Thanksgiving and Christmas. So the next monthly meeting will be in January. If you want any info about that, if you Google OWASP Austin and you get to that page, you can join the list. And we'll send out Eventbrites as well for that. So please join us for that. We also have a monthly happy hour that goes along with that. So free drinks and food. You can't turn that down. And finally, for those of you who are not coming to the rest of LASCON, and if you're interested, LASCON the next 2 days is our annual Texas Regional Application Security Conference. And if you talk to the guys up front, Griff and Kyle, and you are interested in coming to LASCON, they can give you a discount code for attending this training if you would like to sign up last minute to come to the conference. So without further ado, I'm going to introduce our speakers. They're going to be talking about the OWASP Top 10 and provide you an intro on application security focused on developers. So a little bit about them. Josh Sokol is one of the co-founders of LASCON, but is also on the national board, global board technically, of OWASP. So it's great to have someone from Austin representing us on the global board. We've had that before with Matt Tesoro, and it's awesome to have that continuity with Josh on the board. And Dan Cornell, who's also local to Texas from down in San Antonio. Both Josh and Dan have been in the OWASP community. I'll save you the CV bullet points, but they've both been in the OWASP community for almost 10 years or more, and have a ton of knowledge, and you're going to learn a great amount from them. So without further ado, Josh and Dan. Thank you.
Thanks for the intro, Ben. So I'm Josh Sokol, local guy here. How's everybody doing so far this morning? Good? We're tired? We're sleepy? We're quiet? All right, so like Benjamin said, we're going to talk today about the OWASP Top 10. Let's start with a little attribution. So this slide deck actually came from Denim Group. Back in the day, National Instruments actually had an engagement with Denim Group that came out and gave a big training, did a fantastic job kind of training our developers on web application security. And then from that point forward, we kind of modified the deck as OWASP Top 10 changed, we updated it, and it turned into kind of this weird morph of Denim Group / NI content all lumped together. So last year when Dan and I did this training for everybody, we decided, hey, let's put this thing together, let's distribute it under Creative Commons license, and so we threw it up there. So if you would like, I'll give you a second to write down that link. This is the link that will take you to my Dropbox, where you can basically download the PDF version of this slide deck. It'll say LASCON 2015, that's because nothing's really changed. The OWASP Top 10 has not been updated since we last gave this presentation. So pretty much everything here is still applicable. And then oddly enough, a lot of the content that's in this deck is still the original content from back when Dem Group had done this in 2007, I think. And what that really means is that application security is still a huge problem. This is something where things like cross-site scripting, they keep surfacing. They don't go away. I hired a design firm to work on my tool, Simporus, and when it came back, there were like 4 cross-site scripting vulnerabilities in it. So this is a very big problem, and it's a problem that affects all of us. Which is the reason why Dan and I are so passionate about this and decided to do the free training for everybody today. So what exactly are we going to talk about today? We're going to start off and talk about some kind of principles and how to apply those principles. So this will mean an intro, some basic security principles, things that will kind of help you along the way. We'll talk a lot about input validation because it's very, very important. We'll go through the OWASP Top 10, talk about the common vulnerabilities, and then we'll talk about some other things like buffer overflows, denial of service, configuration management, again, input validation because it's that important. And then we'll talk a little bit, if we have time, about security in the SDLC, maybe some elements of the secure design threat modeling. So as Benjamin said, I'm Josh. I run the security team at National Instruments. I've been at NI for about 9.5 years. I've been running the security team there for about 6.5 years. I'm also the creator and CEO of a company called Simporus, free open source risk management. And then as Benjamin said, I'm on the OWASP Global Board of Directors. So if you want to email me, it's just josh.sokol@owasp.org. Or if you want to send a tweet, take a funny picture of me or whatever, post it on Twitter, it's @joshsokol. Dan, you want to introduce yourself?
Howdy, I'm Dan Cornell. It says here I'm the founder and CTO of Dem Group. That's believed to be accurate. And I'm a software developer by background. I started doing a lot of server-side Java stuff in the late 90s, some .NET stuff in the 2000s. But really what I've spent the last probably 15 years of my career doing is looking at how software development impacts the security of the organization and deploying software. So that's kind of my background is as a developer who's come into the world of security as opposed to someone who came up through more traditional like pen testing or systems administration background. As Baka mentioned, I'm up from San Antonio and I help one of the folks that help run the OWASP San Antonio chapter. I'm excited to have the opportunity to talk to you all today.
Is anybody here from San Antonio, by the way? We've got a few. Awesome. The OWASP San Antonio chapter is a great chapter. I've been there a couple times. Highly recommend getting involved. Same thing if you're here in Austin. Getting involved with the Austin OWASP chapter. Our meetings are, they run January through September, and we typically have about 70 people or so. It's at NI. We give you free food and everything. Fantastic opportunity to learn more if you'd like to learn here. So I guess let's start by talking a little bit about what is application security. So application security is ensuring that custom application code performs as expected under the entire range of possible inputs. So no matter what we're going to throw into this application, it's doing what we say it should. And so our goals for this are kind of this traditional CIA, which if you do a CISSP certification, you learn a lot about CIA. Confidentiality, integrity, and availability. And there's a direct relationship between application security and software quality assurance. In fact, some might even argue that application security is kind of a sub-area of software quality assurance. And the reason is that SQA is basically verifying that the software does what it's supposed to do. Application security is kind of like almost the opposite. We're looking at what the software does that's not supposed to do. And so, to put this in a graphical way, in a perfect world, basically what's happening is our actual functionality, what the application is doing, is exactly like the functionality that we intended. So we write the spec, we say that our software should do X, Y, and Z, and when we're all done, the software does only X, Y, and Z. How many of you guys think that that always happens? Right? Yeah, exactly. We all know that the code has bugs, and you wouldn't be here if you didn't know the code had security vulnerabilities. So real world, it actually looks something like this, where our intended functionality and our actual functionality, they're kind of like that, right? So they don't exactly overlap. And in the places where we have actual functionality that's not intended, we have security vulnerabilities. This is the world that we live in. And then on the other side, we have our built features, which is where they do overlap. And on the other side, which is where software quality assurance comes in, is the bugs, right? Where we have intended functionality that's not actually there. And either one of those things can be a problem, right? It's just that we typically tend to focus way more on those bugs than we do on the security vulnerabilities. There are some cultural differences. The traditional information security tends to have this measured culture. We need to determine what's in place, we audit configurations, we monitor the operation of the application. And application development and systems integration has this build culture. It's all about creating something that didn't exist before. And a lot of times this is driven by some sort of project deadline, right? So it's by this date we have to have this functionality done. By this date we're going to do this. So we get into this either waterfall or agile methodology where it's all driven by that functionality. Unless we figure out ways to build application security into whatever methodology we're using for development, we're going to fail. We're going to have vulnerabilities that we can't, we're going to have vulnerabilities, period. So why does this matter? Well, we have lots of business critical web apps that are facing the internet. You look at what happened, a week ago with DIN. I mean, that was a whole bunch of IoT devices, Internet of Things devices that were just online, that had default credentials. People didn't think about securing them or changing those credentials, and all of a sudden they're being used in what's been said to be the biggest denial of service attack in history, right? Brought down one of the biggest providers, brought down DNS, the Internet Critical Application. So to say that this is important is an understatement, right? This is critical to our infrastructure, to our applications, to our data. And when you start talking about what's inside the firewall, the stuff that the internet isn't touching, it gets even worse, right? Because there's even more data that's available to those people. You're talking credit card numbers and social security numbers and health information. There was a study by Senzik, this is a little dated, but 2014, and they said 96% of applications tested in 2013 have one or more serious security vulnerabilities. Now, I would guess, I don't have the data to back this up yet, but I would guess that that number is even higher. I would guess that unless Denim Group is the one writing your application, it's probably close to 100%, right? Because it's just that bad. These vulnerabilities find their way into everything. The other reason why this is really important is because new laws and regulations govern how data is stored and made available. So all over the place, if it's health and health records, then you have this HIPAA that's governing how we maintain that data, how we keep that data safe. When it comes to publicly traded companies, you have Sarbanes-Oxley that goes through and says, this is how you're going to ensure that the data is kept safe and people aren't tampering with your financials. In the case of identity, in California, they have SB 1386, which is a law that basically says, hey, if the California citizens' data gets breached, you have to do notifications, regardless of where your company is based. And then you have, for credit card data, you have PCI. The PCI DSS standard governs how we protect the credit cards. So this is very important, and it's not a problem that's going away anytime soon. So when we talk about vulnerabilities, there's basically two different types of vulnerabilities. We have technical vulnerabilities. Technical vulnerabilities typically surface due to insecure programming languages. It's typically due to some sort of poor input handling or input validation. The good thing is that most of the scanning tools, the Nexpos and the White Hats and Qualys and things like that, they're actually really good at finding this because they basically go, they throw input into the tool, they look at the output, and they say, hey, that does not match what I expect. or that matches a certain signature. And when we find these vulnerabilities, the fix is usually pretty easy because it's just change the code there, update wherever it sits, and we're good to go. Then we have logical vulnerabilities. And logical vulnerabilities typically surface due to insecure program logic. So what this means is that at some point in our business process, we've made a decision about what we're going to trust, and that decision was wrong. That decision said we should trust data from this user, when in fact that user has some way to tamper the data. And so if we're doing things like that, it makes it really hard for a scanner to find it because it's all about the workflow. It's, if this happens, then we have to do this. If this happens, then we have to do this. And so our scanning tools have no way to understand the logic behind how our application functions. All it's doing is feeding an input and looking at the output. And the unfortunate thing is, if we have these logical vulnerabilities, then our remediation means that we have to change how the application works. We have to change the workflow, not just the code, in order to fix that. So this is very, very complicated. If we get to logical vulnerabilities, we're talking about basically rewriting pieces of the application. All right. So talking about the OWASP Top 10, this is the OWASP Top 10. This version of the list was generated in 2013. The team that works on the OWASP Top 10 right now is in the process of creating the next list for I think they're going to release it in 2017. But typically this a new version goes out every 3 years. The OWASP Top 10 is meant to be an awareness document. It's meant to show you these are the most risky vulnerabilities that are out there, the most risky things. And so when we go down this list, which Dan and I will go through every one of these things over the course of the day, we're going to kind of tell you what that is, how it works. We might show you a demo or something like that. And then from there, we'll talk about how to fix it. And like I said, not a complete list. So these are the 10 most, 10 biggest risks, and that's based on either the impact of them or the likelihood of finding it. It represents a broad consensus, so basically the guys who are organizing the OWASP Top 10, they take data points from all sorts of different companies, companies that are doing scanning against applications, companies that do pen tests, and they try to get a feel for where the industry is at in terms of number of vulnerabilities that are out there. If you want a more complete list, OWASP has a really good threat classification project. It kind of goes through all sorts of different vulnerabilities and classifies them into basically a taxonomy of vulnerabilities. All right, so let's talk about basic security principles. The goals for this section is to introduce several general security principles and relate them back to application security, and then set the stage for future discussions of material. And so the things that we're going to cover are least privilege, defense in depth, val close versus val open, and separation of duties. So let's start with least privilege. The idea with least privilege is we want to give a process only the authority that it needs in order to do its job, nothing more. So let's take an example of a program that needs to log to disk. That sounds like a requirement that our business might give us, right? This needs to write a log to disk. Well, when we're trying to interpret what they mean by write to disk, we have a few different ways that we can interpret that. We could give it raw disk access, right? We can make it so that it can write zeros and ones to every sector of that drive. But if we do that, that means that it can overwrite any other data that's on that drive. It can modify any data on that drive. So that's probably our most privilege, right? We could give it read-write rights to a directory. So at this point, we've limited it to just this piece of the disk. And it can do anything to the files that are in that directory. It can modify them, overwrite them, append to them, whatever. But we're at least getting a little bit more granular in our access controls. We could do read-write rights to a file, right? So we've gotten rid of everything else in that directory. It's just that one file. And that one file is what you can log to. Cool. But now we can still write to that file, which means that we can modify the data that's inside of that file. Okay? We can do append writes to the file. And with append writes, what we're saying is that all we can do is write to the end of the file. We can't modify any of the data in it. We can just put more data at the end of it. And so when we're going through this kind of hierarchy, the least privilege would be just the append writes to the file. And the finer grained the security mechanism, the closer we get to least privilege. and the more secure our design is. So this is something that we need to think about as we're writing our application, as we get these business requirements. We need to consider what is the least privilege that we can give this application or this feature request in order for it to still accomplish the business goal, but be more secure. So in application security, what this means is for database access, we have to ask ourselves, what capabilities does the user's database connection have when performing an action? Is there a way that we can limit that connection? Do they only need write access? Do they only need read access? Should the application have the ability to create and drop tables, to grant and deny responsibilities or permissions, right? When can the application tie up multiple database connections? These aren't things that are immediately obvious, but they're decisions that we have to make as we're writing our application. When it comes to file access, we talk about what files can be read or written by the application or web server process. There's certain vulnerabilities that can happen if you have the ability to overwrite a file or write a file into the directory, right? If I have the ability to create my own PHP web page in an application that's servable by the web, well, now I have a way to put a backdoor onto that server. We have to ask ourselves, what are these files used for? Are they able to be executed on the server, like in the case of PHP? What about encryption? Do we need to encrypt those files so that if somebody else gets access to them, they don't have all of our data? And when it comes to user authentication routines, we're asking ourselves, what are the different classes of users and what can they do? What about separation of duties? Do we have a regular user, an anonymous user, an administrative user? These are all questions that we have to ask ourselves. Before I move on to defense in depth, I just want to say, if anybody has questions, I realize that there's a lot of information here, and we're gonna be shooting the fire hose at you guys throughout the day here. But if you guys have any questions, feel free to raise your hand, let us know. We're happy to kind of take a pause and talk about that. So, any questions? Yes, sir.
On the database access,
Yeah.
because a lot of the modern apps use the ORM model to try to control the scheme and all that. Is there any security best practice in terms of how you execute that as you run migration to production and have the code that then controls structures there?
Yeah.
Is there anything in this area that's slightly different than the old school where you DBA team manage the database and application teams manage it?
Yeah, so this question, for those who can't hear, is about specifically with database access and ORM model. Are there any special things that we need to do to handle that? ORM is actually really good. ORM is basically saying that instead of basically handling individual query parameters, we're using like numeric representations and things like that. We'll talk a little bit more about that with the injection clause section of this. And we'll talk specifically about how to protect database queries. We'll talk about parameterized queries. I think there is a note in there about ORM. So I'll hold off on that question for right now. And we'll dig a little bit deeper into this, specifically the database access under the input, or under that section. Cool. All right, any other questions? No? All right. Let's talk about defense in depth. So defense in depth says that we don't want to depend on any single security mechanism. Instead, we want to have multiple independent security measures in place. So I like to think of this as a castle, right? And when you have a castle, what you're effectively doing is you're setting up multiple layers of security, right? The first thing that somebody is going to encounter when they come close to your castle is they're probably going to encounter a whole bunch of sharp pointing sticks poking on the ground. Or in the modern day, it's going to be something like landmines all over the place, right? And hopefully that's a deterrent for enough people to keep them away. But there's always going to be some people that are so persistent that really, they see the treasure that you have inside that castle, and so they're going to persist even though there's that thing in their way. So they keep going, and eventually they get to the moat, right? And the moat's filled with sharks with laser beams on them. And once they get to that moat, they're like, whoa, those are sharks with laser beams, I probably shouldn't jump in the water, right? And so those guys get turned away. But then there's some guys that say, that treasure is worth more than my life, because those laser beams will kill me. So they're like, okay, let's figure out a way across that. So they build a bridge, right? And then they're able to get to the wall. And once they're at the wall, they have to figure out, how do I get over that wall? And then once they get over that wall, there's guys pouring boiling hot oil, right? So when you think about this, there's multiple layers of defense that these guys have put in place that the attacker has to overcome in order to get at whatever their objective is. So what this means is if we don't deploy this defense in depth, we have very brittle security architectures. And it gives us a false sense of security, right? Because what that means is if I break one thing, if all my castle had was just a wall, right? Then all I have to do is build a ladder that's taller than that wall, and I'm in. So we need to make sure that we're putting up enough of these barricades in place to prevent the attack, or at least to keep them out as long as possible. So using defense in depth may prevent the exploitability of vulnerabilities. It also might reduce the impact of the results of an exploitation. And SQL injection is actually a really good example of this. SQL injection, if I have a SQL injection vulnerability, that allows me to pull data out of the database. But if I've done my defense in depth and the data that's sitting in the database is encrypted, even if I as an attacker use that vulnerability, if I exploit that vulnerability and I get the data, I still have to figure out what is the key to decrypt that information. So that's a really good example of where defense in depth is going to reduce the impact of that vulnerability exploitation. One thing to keep in mind here, extra security generally entails less usability. So the more barriers we put in place, the harder we make it for an attacker to get at that treasure. Usually the harder we make it for our users to use the application. So there is a balance here. We can't take our server, seal it up in concrete, and drop it at the bottom of the ocean. We have to make it something that they can actually use. So here's an example. We've got our fictitious company, Acme Inc., or Acme Stuff, and they rely on firewalls to block unauthorized access to their internal network. What if that firewall is misconfigured? Or there's some sort of exploit that allows us to use a valid service like a web server and subvert the process. If the only layer of defense that we have is that firewall, and we now found a way to bypass that firewall, we're in. We've got the goods, we've stolen the treasure, we're out the door, right? Now, if we put defense in depth in place, and we still have that firewall, that's still there, that's our first line, we're blocking most of the attackers that are in that. We're creating kind of that least barrier of entry to try and keep the honest guys honest, right? It's like a lock on the door. We're trying to keep the honest people honest. But now, because we have these other protection mechanisms in place to block the unauthorized access, we're basically making it so that the impact of any individual flaw is decreased because these other mechanisms are going to halt the attack. So maybe they get through the firewall, right? And then we have some sort of file permissions to prevent them from getting that, and that deters some people. And then they get past those file permissions and they get to the point where they're trying to brute force something. And we have strong passwords, and so they're not able to do that. And then maybe somebody finds a way to get past that. And they can even bypass the account restrictions, and they get at the data. But we've encrypted our data. This is what defense in depth is all about. So in application security, defense in depth means choosing when to encrypt database data. It means implementing application-based authentication and authorization mechanisms. It means configuring our deployment environments in a secure way. And it means having some sort of guidance on the installation for our IT departments that says this is how we configure a secure server. Questions about defense in depth? All right. Next, we have fail close versus fail open. This one's very simple. Fail close systems block access when they run into errors. Fail open systems allow access when they run into errors. The problem, the complexity with this is in choosing when you should do it, right? So it has to be done on a case-by-case basis, and there's no right answer. It's not like you should always fail open or you should always fail close. Fail close can usually be considered more secure. So let's look at an example, right? Nuclear missile launch software. Fail open, fail close. What do you guys think? Open? We want that missile to launch if there's a problem. Close, right? So fail close might be the appropriate answer in this case, right? If there's a failure scenario with our nuclear missile launch software, we probably don't want that to launch, so we don't have to fail close. All right, fire door lock software. Fail open, right? Yeah. So if there's a problem and this thing fails closed, we can't open the door, people are going to die. So that's a good case where we want to fail close. What about this? credit card authorization routines. Yeah, absolutely. So fail open in this case might be appropriate if we have hard goods, right? So if there's time to reattempt the transaction before the goods are actually shipped, fail open, right? We can take their information, hey, it failed, but we'll accept that order and we're going to have somebody manually call them. But what if it's a soft good? What if it's something where somebody's buying a book off the Amazon store, right? And all of a sudden we have a failure scenario. Do we want to give them the book when their credit card failed? Probably not, right? Because that's money out the door. They're not going to come back and be like, hey, I got the book, but you didn't charge my card. Most people won't do that. All right. So our risks here for fail close versus fail open is often fail close versus fail open is not specifically addressed. And what that means is when we don't have any specification or testing for how programs are supposed to behave, that can lead us to situations where error handling behavior can actually open us up to vulnerabilities and can cause information leakage. The other thing here is that this is generally not documented in the requirements. Clients don't know enough about security or fail close or failed open to be able to say, yes, when this happens, I want it to fail close, but when this happens, fail open. I've never seen a requirements document that specifically addresses that. In terms of design documents, I think a lot of times people just assume it's easy, right? When that happens, I just do the error, display the message, we're good. What if that message has some information about the password that was used, or the information about the server that could be leveraged in some other type of attack? So we can't just assume that this is easy. We have to actually address it. In application security, this means we have to flesh out requirements for our explicit failure cases. It means implementing common error handling routines. It means code reviews not only for our code, but also our error code, since that's what's going to be displayed in those failure conditions. And it means automated testing not only of the code, but also for our error conditions. All right. The last one here is separation of duties. Separation of duties is primarily a fraud control measure. It's a way that we ensure that that no one person is able to sign off on some high-value transactions. So most of the big companies out there, especially the ones that are publicly traded, what you're going to have, for example, is you're going to have one person that's able to add vendors into the system, people who get paid. And you're going to have a totally different person whose job it is to pay them. The reason why is separation of duties. If one person had the ability to create vendors and pay them, well, then they could create a vendor for themselves, their husband, their family, whatever, and then send a check to them at the same time. And then we have a situation where fraud can occur. So with segregation of duties, separation of duties, we're basically creating a situation where people have to actually collude in order to do that. All right. So at this point, I'm going to hand it off to Dan. I'm going to let him talk to you guys about injection, and then hopefully Dan can help answer your question about the SQL injection and ORM.
Thank you. All right. Fantastic. So, again, the bulk of the rest of the stuff that we're going to be talking about for the day will be going through the OWASP Top 10, 2013 edition. And the first thing that we want to talk about is our injection flaws. And the OWASP Top 10 is, as Josh mentioned, it's a list of the risks to web applications. And injection flaws have been on the list, and number one on the list, I think, or very high on the list, throughout the life of the OWASP Top 10. And the reason for that is that they're very common, and they also have a potentially very bad impact. And as with a SQL injection example, if an attacker can run their own queries on your database, it's not really your database anymore, right? It's kind of their database. And that's, especially if you look at a lot of web applications that are kind of a thin veneer of web pages sitting on top of a SQL database, if an attacker can run the queries they want on that database, that gives them tremendous access to the system, tremendous ability to do bad things. So this is a very serious, very serious problem. It's the type of thing that we find over and over again. So what is an injection flaw? So an injection flaw occurs when untrusted data gets sent to some other interpreter as part of a command or a query. And this allows the attacker's hostile data to trick the interpreter into executing unintended commands or accessing data without proper authorization. So this happens, again, SQL injection is a great example where you have a database and it has an interpreter that is processing SQL queries. If someone can influence the structure or can control the SQL query that is being executed, beyond just saying, well, they're supposed to, send in a record number, or a name to search for, or something like that. If they can change the structure of the query, and we'll look at examples of this, they're taking over that interpreter. And so other examples of situations that you have in web applications where you're connecting your application to an interpreter would be if you're shelling out to operating system commands. That is less prevalent these days than it has been in the past, but it's still the type of thing that we see. Another example can be LDAP. If you're sending a query to an LDAP server, if an attacker can't control that, they may be able to pull back additional data. What are some examples of other interpreters that you might talk to? What's that? Somebody said something. Other interpreters you talk to? What about XML, like XPath queries, things like that? And so the general problem that we're looking for are situations where you are crafting some sort of a command or a query in your application and passing that off to another interpreter to do whatever stuff it's supposed to do. If you don't control the structure of that query, that leads to bad situations. And the impact of this is, again, potentially really severe. In the your database example, if an attacker can read data from the database, if they can write data into your database, if they can delete data in the database, you're going to have a pretty bad day, right? Same thing if you're talking to other interpreters, if they can control the queries that you're running on XML documents, if they can control the way that you're querying LDAP, all of these lead to really bad things. Another great example, if people can control the commands that you're running on, to an operating system prompt, that's really bad as well. And so this can, again, data loss if the data gets deleted, data corruption, lack of accountability because if the data has been modified in ways that your application didn't expect, or it can deny access. And this can also lead to potentially a complete host takeover. And a great example of this is, and effectively Microsoft has done a pretty good job these days of, by default, locking these types of things down or making it a lot harder to turn stuff like this on. But if you look at SQL Server, they have a stored procedure called XP Command Shell that basically lets you run command shell things. So if with an improperly configured SQL Server attached to a web application that has a SQL injection vulnerability, you're potentially giving attackers the ability to run shell commands on your Windows server, right? No bueno, not good. And we've seen in certain high-profile incidents situations like that where you have low-impact web applications attached to a SQL server. Those low-impact web applications, this is for registering people for the company picnic or something like that. Well, if an attacker can identify those SQL injection vulnerabilities, execute shell commands on that server, that database server, and then use that to pivot and target other things in the organization, even that low impact or low criticality web application that maybe isn't receiving a lot of scrutiny can act as an entry point and a jumping off point for a lot worse damage to be done. And so this is something to very much to pay attention to. And again, also speaks to some of the things Josh was talking about from a defense in depth standpoint, saying, obviously I would prefer if my applications did not have SQL injection vulnerabilities, but assuming that some may creep in, let's look at the level of power or level of access that the database user has. Let's look at how the SQL server is configured or the database server is configured. Let's look at how the network is segmented, assuming that we may see compromises. And that's stuff that we'll talk a little bit more about down the road. Yeah?
In order to run a command shell in the SQL server, you have to be an admin on the server, on the database server. So the hacker should be an insider, most probably,
Okay, so your question is running a command shell on the server should require you to be an administrator. The problem specifically with SQL Server is that XP command shell is that's a stored procedure, and if you can exploit a SQL injection vulnerability and call that stored procedure, the web user from the outside can potentially run shell commands on that server. And so you don't need to have the credentials, because the database credentials that you're using to attach the web application to the database server, that is the identity that is used to attempt to execute that that stored procedure, and then that stored procedure attempts to execute commands with whatever permissions that the database user has on that system. And so, sorry.
So in this case, the web application is able to run the command level scripts within the web apps. So the web application has those privileges, which is how they are able to execute it.
That's correct. That's correct. And again, Microsoft has done a good job of locking that down and making that so that that's not the default setup. But I had a buddy of mine runs a company out in the Los Angeles area where he does a lot of software development, and he's got folks onshore that do a lot of the user experience and branding and stuff, and then he's got some different offshore groups that do the back-end development. And he called me one day. This has been a couple years back. But he called me. He's like, Dan, I didn't think that SQL injection. I didn't think that people actually exploited stuff like this. I said, well, yes, they do. And the problem that he had is one of his groups had a SQL injection vulnerability that had crept into the code, had been deployed, had been discovered by an attacker, and the problem was they had, just because it was convenient for developers, is they were attached to the database server as the SA account, or it was a very privileged account. And so that put them in a situation where it was, they basically had to back up the data, slick all the machines in the, in the system, and then reinstall from the ground up, because they had connected to the database with a very high privileged user, and therefore didn't have a good way to do an impact analysis of what had actually been touched. And so that's a problem we see again in the larger enterprises. We see better controls placed around this in certain cases. In smaller organizations that have less of an IT audit type of environment, we see bigger problems. But it's a concern in every organization to look at and say, I've got this database user, I've got this web application talking to the database. What level of privilege does that database user have in case there is some sort of a problem? What's the impact of that going to be?
I think it would be a bad idea for a web user to have a database level admin commands. We should not let a web user to execute the admin level commands to the XP command shell. Best practice would be like a stored procedure or something like that, where the web user can execute the stored procedure and the XP command shell is embedded into the stored procedure.
Right. Well, and I think we're saying the same thing, which is when from a best practice standpoint, you want to constrain. You want to look and say, we're going to have a web user that's going to be attached into the database. That shouldn't be as an administrative user. That should be as a user with very specific permissions that are constrained to what that user needs to be able to do their job and nothing more. So yeah, it's a least privilege. Exactly. An excellent point. So how do problems like this happen? And they can happen any time that you have an application that is accessing an interpreter. And again, SQL interpreters are a great and very common example, but also things like LDAP. If you're making XPath queries, XML stuff with XSLT, HTML, XML, operating system commands. We're going to focus on SQL injection just because that's the most prevalent and I think kind of fits with a lot of people's experience. We'll talk about operating system command injection as well, but the general pattern that you're concerned about is that your web application is crafting some sort of a query or some sort of command and passing that off to some sort of an external interpreter. So, SQL injection. It's over here, so I'm not talking to the two microphones. There we go. All even better. So, has anybody ever built SQL queries like this? I have. It's a very natural way, and I'm not a DBA by background. I'm a developer, and so that means I'm a really crappy DBA, and I speak just enough SQL to get the job done. But that's a very natural way to look at this. Say, okay, well, I need to select. Let's just select star from the user table where the username equals. Okay, well, that's going to be a string, so I need a single quote, double quote. I want to add in the name of the user, and then I need to close it out. So plus. Double quote, single quote, double quote, right? And this is, especially in languages like, like Perl or Python, where like it can be single tick or double tick, kind of depending on whatever. Keeping all that straight. But that's a very natural way to create SQL queries, to append up strings and saying, well, here's what I know I've got. This is what should be passed in. I need to clean up things over here. So that's a very natural way for a lot of developers to create SQL queries or queries to anything. And the assumption is that on the developer's part, the assumption is kind of that like down the middle, everything's fine scenario, which is like, well, if they pass in a username, clearly they're going to pass in a username, and that's going to be, maybe it's an email address or maybe it's uppercase, lowercase, whatever it is. And the developer makes the incorrect or the unwise assumption that the username or the password is just going to have the stuff that it's supposed to have. It's not going to have the SQL control characters. As an attacker, they're going to flip that around and say, let's see how well this developer constructed their database access. Let's start sending in SQL control characters. Let's send in a single quote and see what happens. Let's send in a double quote and see what happens. Let's see if I can, if this developer has made assumptions, let's see what happens when I send in inputs that break those assumptions. And so you can start passing in things like apostrophe or 1 = 1 dash dash. And so what that leads to is, instead of select star from user where username equals D Cornell and password equals password, whatever it might be, instead, when the SQL interpreter gets this string, it sees select star from user where username equals blank string or 1 = 1. Everything else after this is a comma. I mean, and you think that the SQL interpreter is like Pac-Man, right? So it starts with the first character and chews its way through. It's just a state machine running through doing parsing. And so it doesn't care if it is looking for select star from user where username equals D Cornell and password equals password. Like, it'll run that query, or it'll run the query which we see here, which is select all the columns from the user table where the username is blank, which probably is never going to happen, so that would be no rows, or 1 = 1. Well, 1 = 1 is always true, so actually that means all the rows. And so what we're going to see here is, instead of returning the 1 row, assuming the user had a right password, or no rows if the user had a wrong password, instead this is going to return all the rows in that user table from the database, right? And so this is very, very common because it's a natural way for developers to write database access. But the unfortunate thing is it's also really, really damaging. Anybody else have any other commentary? If this is the way I design my login routine for extra bonus points, and I don't have anything to give away, so it's just the respect of your peers in the room, I guess. Anybody else have any commentary on writing a login routine where you do a SQL query for the username and password and return 1 row if it's correct and 0 rows if not? Yes?
One thing to get around that, clearly there's lots of issues with this, but if you know you're expecting 1 row or 0 rows, you should validate that when you get the results before you start sending stuff back. So you can throw one type of exception if nothing's found, like invalid password.
Right.
Or multiple users found exception, right? If it is broken like this.
Right. Yeah, and that's a good, again, an example like a defense in depth feature, thing that you might add just to sanity check to see, am I getting back to something that I expected? That's a good point. Anybody else have a problem with the design of my login routine?
You could enumerate your users.
What's that?
You could enumerate the users and find out whether or not it's valid user or not.
Right. Well, in theory, that's what you're supposed to be doing with this query, where you're saying, I've got a database table with usernames. You're going to give me a username. I'm going to find out if one matches. You're going to give me a password, and I'm going to check to see if that matches. And if both of them match, then I'll return that. Yeah.
Another thing would be to break that down into multiple queries. So I think it's still suggested. And enumerate your users and then do the password.
Right. Also, well, from a design standpoint, what this tells me is I'm storing all my passwords in the clear in the database,
Yeah.
which is also no bueno. Great points. So, with SQL injection, no, that's a button.
It's like that.
There we go. Computers, who knew? So, what are the types of things that we can do if we find a SQL injection vulnerability? Well, the example we looked at just before is we can short circuit the query by overriding the constraints that are supposed to be in place. So if we can add in that or 1 equals 1, we can basically say, I know that you had some criteria that you wanted to limit the rows we were going to pull back, but I'm going to short circuit that, I'm just going to pull back all the rows. We can also potentially retrieve confidential data from other areas. So if we can add, if your SQL query is select these 3 columns from users, but if I add in a query that says union that with select these 3 columns from some other table, I can potentially use a SQL injection vulnerability where the query is pulling data from one table to start pulling data from other tables. Again, because the interpreter doesn't care. It's just, hey, I know how to do SQL. I'm supposed to pull stuff from here. Now I'm supposed to union that with another query from over here. Interpreter doesn't care. You can also potentially delete data, again, by saying, well, end this first SQL statement, and I want to, drop table, whatever, or delete from table where 1 equals 1. So, again, kind of depending on the cleverness of the attacker and depending on the configuration of the database server, identifying a SQL injection vulnerability lets you potentially do a lot of really bad stuff. And so here's an example. Again, you've got your bad guy, they send apostrophe or 1 equals 1. That gets passed through the web application, and the problem actually occurs when that tainted input is sent over and executes on the SQL server or on the database server itself. So here's XKCD. Everybody a big XKCD fan? Yeah, excellent. Has everybody seen the little Bobby tables account before? Name your kids apostrophe Robert apostrophe drop tables. Again, the moral of the story here, we'll talk a little about this more, but and hopefully you've learned to sanitize your database inputs. Here's another fun example that I've seen for folks that may be concerned about things like license plate readers. Right? I don't know if that works or not, but that speaks to the challenge, which is as a developer, a lot of times, like you're just trying to get the job done. Okay, I need to pull the person from the database. If the password matches, cool. Here's a way that I can do that successfully. Or the assumption here, hey, these license plates have 6 characters or whatever. And all the test data that we've ever been given has this set of characters. The assumption is, why would I ever see anything different? Why would I ever see anything weird? Again, the clever bad guys think of ways to break those assumptions or to test to see if the developer has properly taken into account those assumptions. We'll talk a little about,
One of the things, just a little personal story, I was helping somebody as a sysadmin for one of their e-commerce sites, and I think it was just a small site, basically reselling mobile phones. It was PHP app, and it used open cards or something like that. And even though, as the admin, I did everything that was necessary to secure the machine, what I found later, when I got the call, was somebody had completely depleted the site of all the gift cards that they were trading because they had used a SQL injection attack in the open card software itself, which the developer had not thought to test for any of this. So it wasn't even his own code. It was...
Exactly. That's a great example where, again, they've got this component open card. They're just, hey, here's the command to feed the stuff in. You're just passing things along. And because that developer, that component had that vulnerability, that's a problem. Yeah, and that's actually one of the things we'll talk about later in the day is looking more broadly to say, I've written this much code, but the system includes all of this other code. Are there vulnerabilities in these components exposing the system as a whole to problems? It's a great example. Excellent. Any questions about SQL injection, Paul? Good. Okay, so operating system command injection. This is something that we don't see as much. We used to see it a lot. My first company that I started, we did a lot of server-side Java development. I'll talk a little bit about that. But even before that, we used to use a Perl-based shopping cart called shop.pl. I think you get it off Matt's script archive. I don't even know if that still exists, but we sure copied that and used it to do whatever. And that used a file system as a database, right? Because back then it was hard to find databases in the mid-90s or whatever. But you always had a file system, and you were probably running on some form of Unix, and so it used the file system, and it would do things like list directories and whatnot. And there was naming schemes to figure out, like what the products were named, the item IDs, and things like that. And hopefully, I can't think of it, but it would still be running this code. Hopefully not, because I'm sure it was full of horrible operating system command injections. Because to look or to do searches on items and things like that, we would open files and list directories and stuff like that. If we needed to send mail, we would open a pipe to send mail and stuff things in. All kinds of other horrible things. But at the time, that was like, if you wanted to send mail, there wasn't like a really cool component that would send mail for you. You had to shell out the operating system commands that did that. And in the Unix world, that was something that actually made a lot of sense. It fit kind of with the way the tools got chained together in Unix. And so again, this is something we see more commonly in older legacy web applications. We were doing work on a system recently where they have the company has some desktop software that does some pretty sophisticated scientific calculations, and for their cloud version of the system, they have a big Java front end doing all the front-endy stuff, but for these calculations, they've got a couple of Windows machines where they fire off command shells to load data in, do all these scientific calculations, and pull the stuff back out. Like that's from a system design standpoint, they said we don't want to write these hundreds of thousands of lines of code in Java. We're just going to use the thing that we've got and shell out to do this type of stuff. And so even in a very modern cloud-based system, we do see situations where folks are calling out to these command shells. And again, potentially very damaging, because if I can take over the command that's being run in a command shell, that's I'm going to run with the permissions of the application server or the web server. So again, from a least privilege standpoint, from a defense in depth standpoint, that's also something you want to pay attention to. But it would be even better if you didn't have situations where you were where you allowed an attacker control over things that were being passed to operating system command shells. Same thing with LDAP. If you're building LDAP query strings, that can result in the same type of vulnerabilities. Where if you're crafting your LDAP query, if I pass in a star or something like that, I could potentially hijack and make the query do things that you didn't want it to do. So how do you test applications? And the good news is, and Josh talked a little bit about technical versus logical vulnerabilities. These injection flaws are technical vulnerabilities. They are coding flaws with the application. And as a result, they are usually reasonably easy, or you can get pretty good coverage from automated tools to identify a lot of these vulnerabilities. Automated tools aren't perfect. You should not rely on them to fix to find and fix everything. But these are the types of vulnerabilities that you can rely on automation to help you reliably find in a lot of cases. And so if you think about it, like looking at, for a SQL injection vulnerability, as an attacker, I'm going to say, okay, I want to send in SQL control characters and see how the application behaves. Because my guess is that this developer assumed that they were only going to see the type of stuff that they wanted to see. They didn't expect to see this stuff. So I'm going to send in a single quote. I'm going to send in a double quote. And I'm going to see what comes back. If I send in a single quote and I get back a JDBC error message invalid SQL syntax, well, that's a pretty good indication to me that request and response pattern shows me like, hey, that looks like, if I send in the letter A and get a, well, no, I didn't find that user, but I send in a single quote and get an error back, as an attacker, that tells me this is something that I want to investigate further, because that request and response pattern is indicative of those SQL injection type vulnerabilities. And so you want to send in inputs that contain special or reserved characters for that target interpreter, and you want to look for error messages or other
exceptions or some kind of different behavior that you see when you send in those control characters versus sending in the actual the actual inputs that we're expecting. And so once I've identified as an attacker, once I say I'm pretty sure there's a SQL injection here, then they're going to want to go and figure out like how do I craft a payload that is going to give me something valuable back from this, right? So if your SQL query was just an integer, where you have select star from documents where document ID equals whatever that ID is, then we don't have any quotes to deal with, so I can just say document ID equals 0 or 1 equals 1, or whatever else I wanted to do. That's pretty easy. In a case where if we've got like that username example, we've got a single quote, then the place where the attacker can control the payload, and another single quote at the end. So when I craft my payload, I've got to remember like, hey, there's going to be an extra quote attached to a single quote attached to the end of this. Maybe I clean that up with a starting quote. Maybe I clean that up by adding a comment or something like that. And so, what do you want to do with these payloads? Again, kind of depends on what you want to do. You want to modify an existing statement where you change what's coming back from a where clause. You can select additional data via union clause. You can end the current statement and run another. Again, semicolons typically the separator for SQL statements. The good news is that a lot of the default configurations now are a lot better at saying, I want to say that these days, like your default JDBC driver for like MySQL is going to throw an exception if you try to include multiple statements on the same line, unless you specifically set a setting for that. So the good news is that a lot of the vendors have identified these problems and have started to be more secure by default. And obviously that doesn't stop SQL injection from being a problem, but it stops the types of things that you can do. But again, select, insert, update, delete. It's really, the options are limited only by the imagination or the constraints, the input validation, and the database account permissions. Let's see. So let's talk about mitigations for this stuff. Who here has heard about input validation? Good. Does input validation fix SQL injection? No. It helps, which is a great example. And like input, like from a secure coding advice standpoint, like the simplest and most powerful advice that I can give is validate your inputs. Right? And I guess if you go back to the Bobby Tables example, that's kind of what they alluded to as well. And that's great advice. But that doesn't necessarily fix the problems, right? And we'll talk about it in a minute. But from an input validation standpoint, you want to look at things like length, type, syntax, and business rules. If your usernames are expected to be between 8 and 12 characters, well, you probably want a string that's between 8 and 12 characters. If you are looking for a price or a transfer amount, you probably want that to be a monetary looking number, up to 2 decimal points and probably positive. All right, and so that's something that will help stop the exploitation of a lot of problems. Right, so you want to do input validation, very, 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 very important. But what really fixes injection flaws, and as we'll see with things like cross-site scripting and others, what really fixes them is making sure that those inputs that are being passed in are treated as data to be operated on, not code to be executed, right? And so you need to make sure that people can't change the structure of these queries. And there's a couple ways to do that. You can set up stored procedures where you say, well, this stored procedure says retrieve user, and you can pass in a username and string. And that username string is treated as a string, and you basically turn over to the JDBC or the database driver and say, I want to run this query with this parameter, and here's a string. We'll look at some Java-specific examples here in a minute. You can do that with stored procedures. You can do that with prepared statements as well. Again, we'll look at some examples in just a minute. Also, there's some discussion earlier about object to relational mapping tools. ORM tools are great. Because they help in a lot of cases to mitigate some of the problems associated with injection flaws. They don't eliminate them. You can still, if you're using Hibernate, you can still have, there can still be injection flaws associated with those. Typically, those injection flaws are going to impact data that gets pulled out. They're not going to allow you to write data to the database. But one good thing about the object relational mapping tools is they usually do a pretty good job of saying, like, here are objects, what is the selector you want for that object? I'll be in charge of translating that selector into the things we actually pull out. So they help, but again, at the end of the day, a query language passed to those object relational mapping tools is, that's just another interpreter that's going to interpret what you pass in. So they help, but they don't fully solve the problem. Also, from a defense in depth standpoint, you want to turn off verbose error messages, right? If I pass in a single quote and I get back an error message of like error, okay, that's not super informative. If I pass in a single quote and get back well, you had a SQL syntax comment or SQL syntax problem at like this portion of the query right here. Like if I can get that information back as an attacker, that's going to give me a lot more to go on. And again, you want to practice defense in depth and by using least privilege by restricting account permissions. Your database accounts used for web application access should be of a low permission level. In the Java world, and these translate also into .NET. Most modern web frameworks have these things, but they've got in Java they've got prepared statements, callable statements, and again looking at controlling error message. And so what this lets me do here with a prepared statement is I could say I want to update my coffees. I want to set sales equal to something where coffee name is like something, right? And so the string that I'm passing in, that's a static string. An attacker will never have any control over that string because it's a constant inside inside my program. And that's what is going to get sent to the interpreter. And what we can also then do is say, I've got a statement that I'm going to run, and at the first position, I want to set an integer to be 75, and at the second position, I want to set a string to be Colombian. Right? And so that lets me, the structure of that query is a fixed string, and then I get to set values. And it's the responsibility of the database driver in the database to say, okay, well, hey, sales is an integer. I've been given an integer. Great. Coffee name is a string. I've been given Colombian. That's great. If I was given Colombian apostrophe or 1 equals 1, then it's the job of the database driver to go in and put backticks or double quotes or whatever the specific language is, how they handle control characters. It's the responsibility at that point of the database driver to do that. So these prepared statements let you make sure that the structure of your query stay the same, and any escaping that needs to be done is handled by the database. Similarly, if you're calling stored procedures, you can basically say, hey, I've got a stored procedure called show suppliers. It has 2 parameters that are passed in. The first is an integer, the second is a string. And I'm going to set this query up and run it. Again, we're preserving the structure of the query that is being run, so that even if you pass in a bunch of crazy stuff, it's the database driver's responsibility to properly escape that. And also, again, looking at controlling error pages or controlling error messages is another thing that is a good defense in depth. So that when you go into production systems, you're not getting a bunch of stack traces, error messages, and things of that nature. Any questions on any of the stuff that we talked about with injection flows? Yeah.
So it's
No, that's a great point. So like everything's old is new again, or whatever the saying is. And his point was to be very careful because command injection is very common on IoT devices where everything runs as root. You're probably shelling out to operating system commands. Again, much as web servers and things are now went from being less powerful to now being super powerful. Now there's libraries to do everything. Well, in an IoT environment, well, I need to do this. Okay, we'll shell out to this network command or shell out to this other thing. So that's a great point. If you're building or looking at IoT systems, that may the golden age of OS command injection is on its way back. So fantastic. Yeah. Great. Any other questions about SQL injection? Yeah. Cool. We've just got a couple references here. Obviously, the slides and all that are available. And so let's do a 10-minute break now, and we'll be back at 10:25 a.m. sharp.